Hello, this video is on lesson 4.1. It begins on page 176, and this lesson we learn about solving quadratic equations by taking the square root. So what I had you do at the beginning is to simplify all these squares. And so very instinctively you guys were able to give me the answer. Square root of 1 is 1. Square root of 4 is 2. Now let's take a look at why this is. Well, if we take 2 and we square it, it's going to be 4. So you're basically, in order to find the square root, what you're asking is, what number do we square in order to get the number that's inside the square root? So what number times itself gives me 9? Well, that's going to be 3 times 3. So square root of 9 is 3. And if we keep on doing these other ones, we get 4 and 5. Now, so my classes were able to get these answers, but then I asked them, there's actually an extra answer for all of these. So if we take a look at the square root of 4, 2 squared gives me 4, but what other number, when I square it, also gives me 4? So it took a while, but eventually negative 2 squared also gives me positive 4. And so as you can see, for each of these square roots, if we take the positive and the negative number, we're going to have 2 answers for each of these. So in order to represent this, you put plus or minus for each of these, because the positive answer and the negative answer are going to be both of your answers. And so whenever you take the square root of anything, your answer will always have a positive and a negative. And so we call this plus or minus 1, plus or minus 2, plus or minus 3, and so on. And so your whenever you take the square root, you always have the symbol plus or minus. Okay, so we began on page 176, and we read the paragraph here. When solving a quadratic equation of the form ax squared plus c equals 0, by taking square roots, you may need to use the following properties of square roots to simplify the solutions. And so we went over 2 properties of square roots. The product property of the square roots. The square root of a product equals the product of the square roots of the factors. And so when we're talking about products, we're talking about when we're multiplying square roots together. And another thing we talked about was the quotient property of square roots. The square root of a fraction equals the quotient of the square roots of the numerator and the denominator. And so when we talk about quotients, we're talking about dividing square roots, which is what we see here. Okay, so how are we going to use these properties? Well, first of all, let's take a look at the square root of 9 over 25. Now, what we want to do is to simplify this. Here we have just one square root. What we want to do is separate this into 2 square roots, a square root in the numerator and the square root in the denominator. And so what goes in the numerator is basically the number that is on top there, that's 9, and then in the bottom is going to be 25. Okay, so can you see how we took the quotient property of square roots from one square root into 2 different square roots? And basically, let's see what we have now. Can we find the square root of 9 and the square root of 25? Well, yes. That's going to be 3 over 5. Remember, these are both perfect squares from here. And remember, every time you take the square root of something, you have to put plus or minus. Now, both of these would be, if we had them individually, they both have plus or minus, but we just need to write it down once, basically, plus or minus 3 over 5. Alright, so that's how you use the quotient property of square roots. Now, what about the product property? Well, take a look at this. Here we have the square root of 20. Well, is that a perfect square? Well, we went from the square root of 16 and we skipped over to the square root of 25. So anything between 16 and 25, they're not square roots. Perfect squares, I mean. Square root of 17 is not a perfect square. 18 is not a perfect square. 19, including the square root of 20. So if I take the square root of 20, it's going to give me a decimal. But I can go ahead and simplify this. How do I do that? Well, if I take 20 and find all the different factors, basically 2 times 10, 5 times 4, and the usual one is 1 times 20. Okay, so I came up with 3 pairs. Now there's one specific pair that I want to use, and that's going to be 5 times 4. Now why am I going to use this one? Well, because remember that my perfect squares consist of 1, 4, 9, 16, and 25. I want to use factors that contain perfect squares. In this case, the only perfect square that I see in my pair is going to be 4. And so this is why I use 5 times 4. And so now what I can do, I can use the product property of square roots, and instead of writing 20, square root of 20, that's going to be the square root of 5 times 4. And again, I'm going to take that single square root and separate it into 2 different square roots. Where here are my 2 square roots, and again I'm multiplying these together. On one square root I have one factor, which is 5, and the other square root I have my other factor, which is 4. And now this is why I wanted to get a perfect square, is because I know what the square root of 4 is going to be. It comes out to a whole number, and so the square root of 4 is going to be 2, and the square root of 5, well, I can't simplify that any further, so it's just going to be the square root of 5 times 2. Now, you always want to have plus or minus in your answer. Don't forget it whenever you're taking square roots. Now, this is just my preference, so I wanted to write the number 2 first, and then the square root of 5. And so this is how I'll leave my final answer, 2 times the square root of 5. So can you see how I broke 20 into factors that included a perfect square, and I broke it down into 2 square roots, and that enabled me to simplify into this form right here. Okay. So now what we want to do is solve the quadratic equation by taking square roots. So now we have equations where we need to solve and be able to solve for x. So again, here we have PEMDAS, but it's in reverse order, where the first level we need to look for addition or subtraction, second level is multiplication or division, third level is exponents, and finally parentheses is last. So first of all, do I have any addition or subtraction here? Yes, I do. I'm subtracting 16 here, so I want to do the inverse of it, which is to add 16 to both sides. And so what I get is 2x squared is equal to positive 16 that takes care of addition or subtraction. Now, do I have any multiplication or division? Well, here I have x2 times x squared equals 16. So what I want to do is do the inverse of multiplying by 2, which is to divide by 2. And so what I have is x squared is equal to 16 divided by 2 is 8. Okay. Now, my next level is exponents. And here is where I have x squared. My exponent is 2. So what is the opposite of squaring something? Well, going all the way back to my do now, when I squared 2, it got me 4. So how do I go back from 4 to 2? By taking the square root. And so that's what we need to do to both sides. We need to take the square root of both sides. And so the square root of x squared, well, that's going to be x. And here's where we need to again determine if we can take the square root of 8. Is 8 a perfect square? Well, go back to your list here. You can see how we have the square root of 4, but then we jump all the way to the square root of 9. So that tells me that 8 is not a perfect square. But if we take 8, notice that when we take the factors of 8, one of the factors is a perfect square. So that means I can write 8 as the square root of 4 times 2. And using the product property, I have two square roots, wherein one of them is my factor of 4 and the other one is the factor of 2. So now if I take the square root of 4 times the square root of 2, the square root of 4 is going to be 2 plus or minus, and the square root of 2, well, that's not a perfect square, so we just leave it like that. And there's my answer. X equals plus or minus 2 times the square root of 2. Don't forget your plus or minus, always part of your answer. Okay. So what I want to do is show you an example such as this one, where there's an added extra step. So let's go ahead and go through the steps of this. Again, you want to follow reverse PEMDAS, which I call SAD MEP. So do we have addition or subtraction? Nope. Do we have addition or multiplication or division? Yes, we do, because this is 2 times x squared equals 1. So what is the inverse, the opposite of multiplying by 2? We have to divide by 2. So what we are left with is x squared equals 1 over 2. Alright, again we have x squared. We solved for x squared, and so now we need to take the square root of both sides. So the square root of x squared is just going to be x. And again, notice how we use the quotient rule whenever we had a fraction. We can separate the square root of a fraction into two square roots, where we take just the square root of the numerator and the square root of the denominator. So the same thing we want to do here. We write two square roots, and what goes in the top one is the numerator, what goes in the bottom one is the denominator. Now, is one of these a perfect square? Yes. The square root of 1 is going to be 1. And what about the square root of 2? That's not a perfect square, so we just have to leave it like that. And don't forget your plus or minus. Now, as you can see here, we have a square root in the denominator. And in mathematics, we don't want a square root in the denominator. So what we need to do is something called rationalize the denominator. We don't want a square root in the denominator, so we need to rationalize. Now it's just a very simple step. What do I have in my denominator? I have the square root of 2. So since I have the square root of 2, I'm going to multiply both top and bottom by the square root of 2. And when I do that, x is equal to plus or minus 1 times the square root of 2. Well, that's just the square root of 2. And what is the square root of 2 times the square root of 2? Well, since I'm multiplying them, the same square root by the same square root of 2 squared is basically another way you can write it. What happens is that the square and the square root, since they're opposites of each other, they actually cancel each other out. And so what you're left with is just 2. And so the square root of 2 times the square root of 2 is going to be 2. And here's my final answer. So my final answer would have been plus or minus 1 over the square root of 2, but we don't want a square root in the denominator, so we have to rationalize the denominator. Just multiply by whatever you have here, both top and bottom, and when you multiply a square root times itself, the square root cancels out and we have whatever number is inside. So my final answer is x equals plus or minus square root of 2 over 2. Alright. So now, I gave this question to my students. So we know how to find the square root of, we know the perfect squares. And so if we didn't know any better, we'd just say this would be 1, this would be 2, this would be 5, this would be 3. Going all the way back to our perfect squares here. And of course you don't want to forget your plus or minus, plus or minus, plus or minus, plus or minus. But what do we have different here compared to this right here? Well, each of these has a negative. So these are not, if we're very close to the answer, but these are not the correct answers. And we have to introduce a new symbol. And just like we have a symbol for pi, pi represents a number. Pi is equal to 3.14159 and so on. This symbol pi represents that number. So there's actually a symbol for the square root of -1, and that symbol is I. Now don't confuse this with a J. J has the hook pointing to the left. I like to write my I's like this. And so the answer to the square root of -1, that's going to be I. That's it right there. And so from now on, we have to remember this. Just as we remember pi is equal to 3.14, I is equal to the square root of -1. So now, how can we find the answers for the rest of these? Well, remember, using the product property, we can actually separate these into 2 square roots, but I only have one number here. Well, actually, since all of these are negatives, we can actually separate a -1, and actually, let me not skip any steps here. This would be the same thing as -1 times 4. because 4 times negative 1 gives me negative 4. And so using the product property, I can write it as the square root of negative 1 times the square root of 4. And so when I solve this, I know that the square root of 4 is 2, and I just learned this, that the square root of negative 1 is I. And so here is my answer, plus or minus 2i. And I can actually, since I already know what the square root of 25 is, and I already know what the square root of 9 is, all I have to do is write 5, and then because I have to remember that I do have the square root of a negative 1, I have to simply write I at the end. So plus or minus 3i for my last one. So because I have a negative inside the square root, that means that my final answer will have an I. So can you see that for all of these, it's basically the same thing as this, except we added, because it's negative inside the square root, we added an I to it. Alright, so let's take a look at an example that helps us use this new information. Here again, doing the same thing. In order to solve an equation, we have to use reverse PEMDAS. So first of all, we want to look for addition or subtraction. Here we're adding 12, so we have to do the opposite, which is to subtract 12. So we're going to have x squared equals negative 12. I don't have any multiplication or division, but I do have a squared. The opposite of squaring something is to take the square root of both sides. The square root of x squared is x, and here I have the square root of negative 12. Now, remember, what I can do is separate that negative 1, and then I have positive 12. Now, going all the way back to the very beginning, is 12 a perfect square? Nope, because I go from 9 into 16. So all those numbers in between are not perfect squares. That means that my next thing I want to do is find the factors of 12 that might contain a perfect square. So I have 2 and 6. Those don't contain perfect squares. What about 4 and 3? 4 is a perfect square, so I want to use these two factors. And so negative 12 now becomes negative 1 times 4 times 3. So as you can see, I have 3 different factors inside, and then when I multiply them together, negative 1 times 4 times 3 gives me back the square root of negative 12. So what I can do, since I have 3 factors, I'm going to have 3 square roots for each factor. So here we have negative 1, here we have 4, and here we have 3. So all I have to do now is just simplify each of these. The square root of negative 1, well, we just learned that. That's going to be I. Square root of 4, that's a perfect square, which is 2. And is 3 a perfect square? Nope. So it's just the square root of 3. And don't forget to write plus or minus. So my final answer, this is how I like to write it. You write your whole number followed by your square root, and finally I. Always have plus or minus at the beginning. Here is my final answer. There it is. Alright. So we learned 3 important things. Let's review over those 3 important things. The first thing is that whenever you take a square root, if it's a perfect square, you're going to get a whole number, and every time you take a square root, you always have plus or minus. That's the first thing. when you're solving, the next thing that we learn is the quotient property and the product property. Now, when you're solving a square root, an equation by taking the square root, if you have a square root in the denominator, you have to rationalize the denominator just simply by multiplying whatever square root you have in the denominator. So for example, if I had 1 over the square root of 5, you multiply both top and bottom by that square root of 5. So it's whatever you have here is what you multiply. And so when you simplify this, you get square root of 5 over 5, because these square roots basically cancel each other out. And don't forget your plus or minus. And finally, the last thing that we learned was that the square root of -1 is equal to I. Alright, so that does it for lesson 4.1. Thank you for watching.